So this is going to be a quick one-take video on these additional examples from the notes. These are all related to the ratio test. We're going to solve them with the ratio test, even if there's some other way that we could do them. Let me jump right into that. For all of these, I'm going to go through and take the limit as n goes to infinity and write them as a sub n plus 1, and then multiply that by the reciprocal of a sub n. So we'll do this for all of them just to make our division a little bit faster. Make sure that you're replacing all of the n's with n plus 1. In this factorial, we're going to end up with 2n, 2 times the quantity n plus 1, and so that's going to look like 2n plus 2 quantity factorial once we distribute that 2 through. And then our reciprocal is just going to be our 2n quantity factorial 2 to the n. And then we're going to cancel that. The 2n plus 2 factorial, we're going to write that as 2n plus 2 times 2n plus 1. And then the rest of that product would look like the 2n factorial. And so we can cancel the 2n factorial, and that will leave us with these two terms in the denominator. And then in the numerator, the powers of 2 will cancel. We'll be left with just 2 there, and then dividing that by, again, the 2n plus 2 and the 2n plus 1 that we have remaining there. So just to illustrate the cancellations a little bit more, this and this are canceling out, and then all of these powers of 2 cancel with all but one of those powers of 2. And that limit, then, we've got just a constant in the numerator. We've got 4n squared if we want to expand that out, but as n goes to infinity, this is going to go to 0. And that is less than 1. So by the ratio test, this series converges. In the next one, we're going to set up our same limit as n goes to infinity of a sub n plus 1, which is going to look like n plus 1 quantity squared. 2 to the n plus 1 plus 1 will be 2n plus 2, or 2 to the n plus 2, and this will be 3 to the n plus 1. Multiply that by the reciprocal, 3 to the n over n squared times 2 to the n plus 1. And then we can go through and do some cancellations. We're going to get those terms canceling out. We're left with a 3 in the denominator. Cancel all of this 2 to the n plus 1 with most of these. We'll have a 2 in the numerator, and that's going to lead us to a limit as n goes to infinity of the absolute value. We're going to have our n plus 1, and in this case I can also drop the absolute value because everything's already positive to begin with. Let's see, our constant terms, let me write those down first. I'm going to get 2/3 there. We're going to have n plus 1 divided by n. That's going to be squared. When I put those together, we can write this as 1 plus 1 over n inside also, and that's going to go to 0, and so our limit overall is going to be equal to 2/3 times 1 plus 0 squared, so just 2/3, which is less than 1. So by the ratio test, this series converges. In the next one, we've got n factorial over n times 3 to the n, and I think I meant for this to perhaps be something else, because I could just cancel the n and the n factorial and write it as n minus 1 factorial. Let me just leave it the way that it's written out here, though, and we'll simplify that later. So I'm going to have n plus 1 factorial divided by n plus 1 times 3 to the n plus 1, and then times the reciprocal what we started with, and then we can do some cleaning up and canceling. Again, this n plus 1 I'm going to write as n plus 1 times n factorial, and we'll get a cancellation there, and I can go ahead and cancel this n plus 1. With that, these will cancel out. So we're left with just the n up here. And then we're going to have our 3 to the n canceling with most of these, which means that overall this is going to look like the limit as n goes to infinity. Again, I don't need the absolute values here. This is going to look like n over 3, and that's going to approach infinity, which is definitely greater than 1. So by the ratio test, the series diverges. And then in the next part, and that's the last one in this group, let me scroll up so that can stay on screen there. We're going to take the limit as n approaches infinity. Again, same setup. We'll take a sub n plus 1. That's going to look like negative 1 to the n minus, or n plus 1 minus 1 will just be to the n. We'll have 3 to the n plus 1, dividing that by n plus 1 quantity squared times 2 to the n plus 1 times the reciprocal, n squared 2 to the n, negative 1 to the n minus 1, 3 to the n in the denominator. Go through and do our cancellations. The absolute values are going to take care of the negative 1 powers, so don't worry about those. And then the rest of our cancellations are going to look very similar to what we've been doing. This 2 to the n and 2 to the n plus 1 will cancel, leave us with a 2 in the denominator. 3 to the n, 3 to the n plus 1 cancel, leave us with 3 in the numerator. And then I'm going to go ahead and put my n squared and n plus 1 squared terms together as I rewrite this. We've got 3 halves times n over n plus 1 quantity squared. That limit on the inside, however you go about that, either recognize it as a rational function, divide everything through by n, or use L'Hopital's rule. You're going to get a limit of 1. Inside, squared is still equal to 1. This is going to be equal to 3 halves, which is greater than 1. So by the ratio test, the series diverges. And that wraps up that set of examples. So we're going to stop the video there.